Hi, I'm Joel Sokol, Director of the Master of Science and Analytics degree at Georgia Tech and a professor in Georgia Tech's Stewart School of ISYE. In this lesson, we'll talk about detrending data, what it means, when you'd want to do it, and a basic method for detrending. As you might have already seen in the lessons on time series data, the word trend refers to data that's increasing or decreasing over time. For example, here's a graph of the price of gold at the end of the year over the last 45 years. You can see that overall the price of gold has been increasing over time, but that's not the whole story. Because of inflation, the relative value of a dollar has been decreasing, and that gives an upward trend to the gold price, just like to the price of almost anything else. If we adjust for inflation rates over time, we get this graph. Once we've adjusted for inflation, we can see more clearly the true fluctuations in the price of gold relative to other things, without the upward trend getting in the way. That's what detrending can do, and the reason we want to do it is because the trend in the time series could mess up a factor-based analysis. For example, suppose we wanted to use a regression model to estimate the price of gold as a function of other factors. With trend in the price of gold, we could have the same factor values in 1974 and 2009, but we'd have a very different response value. On the other hand, after taking away the effect of inflation, we can see that the baseline price of gold adjusted for inflation is about the same in those 2 years. And it's not just the response that we might want to detrend, it might be that some of the predictors also should be detrended. In general, you should at least consider detrending whenever you're going to use a factor-based model like regression, support vector machines, etc. to analyze time series data. That just leaves the question of how to detrend. In the gold price example, I was able to cheat a little bit. There are plenty of websites where you can find historical inflation rates, so it was pretty easy for me to adjust each data point individually by the amount of historical inflation. But in most cases, we don't know what the trend has been in the past, except for the data we're trying to detrend. So one simple way of doing the detrending is to go factor by factor and fit a one-dimensional regression to it. Usually that's a linear fit, like y equals a0 plus a1 times x, but you could use a more complicated function too. Let's see the gold prices again using a linear fit. A simple linear regression gives us the estimate that the price equals negative 45,600 plus 23.2 times the year. To detrend the data, we just subtract the trend line estimate from the real price. So the detrended price is the actual price minus negative 45,600 plus 23.2 times the year. As you can see, it's not so different from the inflation-adjusted graph. It's a little different because the linear fit assumes a constant rate of inflation, and the inflation-adjusted graph accounts for different inflation rates year by year. But if you don't have inflation data, you can see that the simple detrending procedure still works pretty well. And that's all it is. Compared to a lot of other analytics models, this detrending approach is pretty simple, and it usually works pretty well as a way to remove trend effects from time series data when you want to use that data in a factor-based analysis.